We're going to add to our understanding of fiscal policy a little bit with something called the multiplier. And in this one, we're going to think about the idea that if the government spends $100 and hires someone to build a bridge, that construction worker is going to take that $100 and they're going to spend some portion of it, maybe all of it. Let's tell a little story here that construction worker then goes and gets a hotel room, right? They're working out on the roads. You get a hotel room, they have to spend money, and they buy a couple of board games. Maybe they buy Twister to play with their construction worker friends, because that's a totally normal thing. And maybe they buy some apples to apples, right? Because they're going to play some apples to apples. And they have all this consumption spending. That spending goes into the pockets of another worker, right? So the person who sold them Twister and apples to apples. And that little game shop store owner now has more money. And that GameStop store owner takes the money and goes and buys Chipotle burritos and Qdoba burritos and El Maguey burritos. Basically, they love burritos, and they buy a zillion burritos from different places. And now that money filters into someone else's pocket, and so forth, and so on. So it's like a rock, right? A rock being dropped into a pond. And in that pond, there would be ripples, right? Ripples. Splash, right? Splash, and there would be ripples if there was. And what we're saying here, and that's a terrible drawing, by the way, of a rock being thrown into a pond. The idea is that money, the initial 100, right? The initial 100 gets multiplied and gets maybe transformed into $300 worth of output. So increase government spending by 100, or increase overall output by 300. And to answer how might this happen, we have to do this lecture. So this is an important part because it basically says that you don't want to overshoot the goal, right? If you're in a recession and the gap is $500, you don't want to initially spend $500 because that would easily close the gap and then it would be multiplied. So you might push this into an expansionary gap. So this is why we're going to try to figure out this information. Now, first the basics. A little bit about income. Households get their income from selling primarily labor, is what we would say here. So it's mostly labor they sell. And when they get their income, we'd say they have this gross income, which is sometimes called total, and they subtract taxes and they add some transfers to some people, and you get something called disposable income, DI. And if you have DI, you can do two things with it. You can consume and you can save. That's all that you can do. You can't do anything else, right? You put money in your wallet, that's saving. You put money into the stock market, that's saving. You put money into your savings account, that's savings. You put money under your bed, that's savings. If you buy any financial assets, so stocks, that's savings. So anytime you're not consuming goods and services, you're saving. Good. Now, the next part is going to be something called marginal propensities. And what we're saying here is the likelihoods of what you're going to do. And it's the marginal, so the additional is what we're talking about. So if I said that you got a $1,000 raise, then that's the additional money that you get. And some amount of that additional $1,000 you are going to consume, and some amount of it you will save. And so let's say for a moment that you increased your DI, and then it will produce some increase in your consumption. But what's the proportion? Well, this is going to tell us. This is the ratio of those two values. So this is MPC is equal to the change in your consumption divided by the change in your disposable income. And that number, MPC, is your marginal propensity to consume. It's that ratio of these two things. It's saying your disposable income went up by, let's say, 1,000, and if your consumption rose by 800, then your MPC is 0.8. And that tells us the ratio between these. Now, this number is going to be useful for us along with the other one when we're figuring out the answer to this type of problem. Down here, we have marginal propensity to save. It's the same idea, but it's saying, like, what is your likelihood to save? So if you have a change in disposable income and you have a change in savings, it tells you the ratio of those two things. So maybe positive 200 over positive 1,000. And the reason we use 200 here, well, you can only consume or save. So if you already consumed 800, then you know that you had to be saving 200, and so the MPS is 0.2. Now let's do a couple of calculations here. Okay? And the first one's done for you. Disposable income went up by 1,000, and consumption went up by, how much is that? 900. So this is 1,000. That's 900. So it's 900 over 1,000 is 0.9. So we're going to put that here, 9, just as an example, right? And then you can see that their savings went from negative 100 to 0, so that's a positive change of 100. And we know that that had to be true because their total disposable income went up 1,000. So 100 over 1,000 is 0.1. Now let's do the next one. Change is 1,000. Change in consumption is 800. So 800 over 1,000 is 0.8. And then let's do the next one, 1,000. The change here is 700, right? So each time we're dropping, it looks like by 100. Change by 700 is 0.7. Then you have another 1,000 and a change this time of 600. So it's 0.6. Now notice the change is important here. It's the marginal. It's not the total. We don't care about the total. It's the change. And then the last one is 1,000 and 500. And so we've got 0.5. Now, there's an easy way and a hard way to do the MPSs. I'm going to show you the hard way first, and then maybe some of you smart little whippersnappers will figure out the easy way. If we know the change here then is 0 to 200, right? So then 200 over 1,000, because each one of these is 1,000. 200 over 1,000 is 0.2. Now the change here, 300 over 1,000 is 0.3. Oh boy, are we starting to notice the easy way? And if we read this, the sum of MPC and MPS always equals 1. If you add these two together, it's always going to equal 1. So this one has to be 0.4 and 0.5. Why? Because you can only save or spend. Save or consume. That's it. So if you are given a problem, this is the really tricky kind of problem you're going to get. It'll say the change in consumption was 800. 800 change in C. And it'll say the change in income was 1,000. Change in disposable income. And then it'll say, what's the MPS? And a huge number of students will go, I don't have enough information. But not you. You're smart. You're going to know, well, if the change in consumption is 800, then that means $200 had to be the change in savings, so the MPS is 0.2. You're a smart kid. You're going to be able to figure that one out. They won't trick you on a test. Now, we're going to take these things, because this is the important part. We need these numbers to be able to figure out the actual spending effects. Now, a lot of words here. What I'm going to summarize for you is pretty simple. You have some change in government spending or change in investment. And that's right down here, an initial increase in government spending or government investment spending. Multiply that, right, times 1 over MPS. And what that's going to yield is the change in output, the total change in output. So maybe it would be a little easier if I wrote it right over here as well. So the change in G or I, right, times 1 over MPS equals change in the output. And that tells us the total change in the amount of total aggregate demand. So test question, right? You ready for this? Test your knowledge. Government spending goes up by 100. Okay. MPS is 0.2. What is the total change in Y? Okay, now, a zillion students over the years are going to be like, so the spending multiplier is 5, right? 1 over 0.2 is 5. So they'd say SM, spending multiplier, is 5. And I can't tell you how many students over the years would take that 100 and divide it by 5 and say 20. But I don't know why you do that. Don't do that. It's in the name. Multiplier. Multiply. You can do it. Multiply. So take the spending number that you're given, 100, and multiply it times the 5. Okay? 100 times 5, 500. So that is key to remember. It's called the spending multiplier because you take the initial spending and you multiply it by the spending multiplier. Okay, now let's do the tax multiplier. This one is a whole lot of words, but the easiest way to remember it is actually that it's 1 less than the spending multiplier. So if we know that the tax multiplier is 5, or sorry, if the spending multiplier is 5, then that means the tax multiplier has got to be 4. Now, an important caveat to that is actually it's more effective or more correct technically. And then on a test, you would need to do it this way. You'd have to flip the sign. So instead of it being 5, it's actually to 4, it's actually 5 to negative 4. So it's better to say 1 minus the 1 over the MPS. So if it were like 1 minus 5, then it would be negative 4. And the reason that we do that is because if, let's say, we changed taxes, right, and we multiply it times this value, 1 minus 1 over the MPS, that will tell us the change in output. So let's say we raise taxes by 100 billion, or 100. We go up, taxes go up. We know that the amount of output is going to go down. You raise taxes, output goes down. So in order for that to be true, then this number also has to be negative. Because if you have a positive times something to get a negative, this has to be negative. So 1 minus 1 over 0.2 is 1 minus 5, negative 4. So this would be negative 400. So we would say that maybe the tax multiplier is 1 less than the spending multiplier, but we flip the sign. And it would be true if we cut taxes as well, right? Because if we said negative 100, cut taxes by 100, times negative 4 should yield a positive increase in output, because cutting taxes should increase output. So just kind of remember that the tax multiplier is 1 less than the spending multiplier, and it is the negative sign. Now, the reason, this is useful to understand the reason as much as it is like how to calculate it and why it's different. The why it's different is important here. The simple answer is when we go back to the ripples in the pond. The multiplier here for government spending becoming the 300, well, we could just say the spending multiplier in this case would be, spending multiplier would be 3. We know the tax multiplier would be negative 2 in that case. But the reason why this number is smaller is because the throwing the rock into the pond happened with the initial $100. That was when government hired a worker to build a bridge. That initial 100 counted in GDP. But if I cut taxes by $100, that initial $100 tax cut doesn't count into GDP. So the first ripple in the pond, right, thinking about all these ripples out, the first ripple doesn't happen. So that's why this number is 1 less, is it's 1 less ripple in the pond. And it's negative because we have to account for the fact that by raising taxes, you actually are decreasing output, or by cutting taxes, negative taxes, you're actually increasing output. So that's why these two numbers are different. So hopefully this helps you understand a little bit about the multiplier, how we figure it out, and a little bit about these marginal propensities. I'll see you next time.